Hello everyone, welcome to the quadratic functions review. Let's start by reviewing the different parts of a parabola. Anytime you graph a quadratic function, you will get a parabola on the graph. So here's an example of one, and I've highlighted a few key points. So this is just about terminology. What are these points called? Well, you have the vertex, which is either your maximum or minimum point, depending on which way the parabola opens. You've got your y-intercept, where the parabola intersects the y-axis. And you have your x-intercepts, where the parabola crosses the x-axis. X-intercepts are also called zeros. And you might have two x-intercepts. You might just have one x-intercept. Or you might not have any x-intercepts at all, depending on how your parabola opens. Now we also looked at three different ways of writing the equations of quadratic functions. We have standard form, factored form, and vertex form. Now the numbers in the equations tell us locations of key points on the graph. If we look at the standard form, the constant term in the equation tells us where the y-intercept is. In the factored form, the numbers in the factors give us an indication of where the x-intercepts are. And in the vertex form, these numbers that I've highlighted indicate the location of the vertex. So if you know all three forms of the equation, you can figure out the coordinates of these major points, the x-intercepts, the y-intercept, and the vertex. So if you come across a word problem, for example, look at what form the equation is written in that you're given, and that can help you start drawing a sketch of the graph, because you'll know which point or points you can label. Now, if you need information from one form of an equation and you don't have it, you're going to have to change the equation that you do have into the desired form. So we can change factored form to standard form. We can change vertex form to standard form. We can change standard form to factored form. And we can change factored form into vertex form. Now, if you're going to change to standard form, regardless of whether you're starting with factored or vertex form, you're going to expand and simplify. Now, just a reminder of what that means, I've drawn a little prompt here for you. Why don't you pause the video and try to turn this equation into standard form, and also turn this equation into standard form. In both cases, you should be getting the same answer, y equals negative 4x squared plus 16x plus 48. If you had issues with that, you should pause the video and ask for help before you move on. Otherwise, try to change standard form to factored form. To do this, we factor the equation. So factor this and see how you do. In this case, minus 4 was a greatest common factor, and this factor is a simple trinomial. So we need two numbers that multiply to negative 12 and add to negative 4, 2 and minus 6. So this is the factored form. Now that we have the factored form, let's practice turning that into the vertex form. So you can expand and simplify this to turn it into standard form, and then complete the square to find the vertex form. We already turned it into standard form up here, so I just skipped all the work. We have standard form. Now complete the square. So we group the first two terms with an x, and whatever the lead coefficient is, that's the common factor. Now we turn that into a perfect square trinomial by taking half of this number and squaring it. That's what we add and subtract. The perfect square trinomial gets factored. Then we expand, and we simplify, and we end up with the vertex form. So changing from one form to another is a good skill to know how to do. It involves expanding and simplifying, factoring, and completing the square. We also looked at operations with radicals. So in each of these, we're going to simplify Why don't you see if you can simplify the first one? See if you can remember how to do that. Pause the video and try it. Remember, we multiply into the brackets. When we have a root multiplied by a root, we multiply the numbers within the root. And when we have numbers outside the roots, they get multiplied together. Now look at the number in the square root and see if you can simplify it. Look for those perfect squares as factors of the number. Remember, perfect squares are 1 squared, 2 squared, 3 squared, 4 squared, etc. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, etc. 9 is a perfect square. That's the highest perfect square factor of 18. Square root of 9 is 3. So negative 2 times 3 is negative 6. I can simplify negative 2 root 18 to negative 6 root 2. You want to get your radical as low as possible. All right, now we have a binomial multiplied by a binomial. See if you can expand and simplify this expression. Remember to expand and simplify. 5 root 6 times 5 root 6, well, 5 times 5 is 25. Root 6 times root 6 is root 36. 5 root 6 times minus 3 is minus 15 root 6, and I keep going. Positive 3 times 5 root 6, positive 3 times negative 3. Minus 15 root 6 plus 15 root 6 add up to 0. Root 36 is 6, so I have 25 times 6 minus 9. That ends up being 141 when I simplify it. Now see if you can simplify this expression as much as possible. Start by simplifying the root, and then see if you can reduce the fraction to lowest terms. The square root of 8 simplifies to root 4 times 2. Root 4 is 2. Common factor of the numerator is 2. 2 on the top, 2 on the bottom. They cancel out. I'm left with 2 plus or minus root 2. If you have questions or you needed help or you're still not sure about operations with radicals and how to simplify these, you should pause the video and reach out before you move on. Another skill we talked about in this unit was solving quadratic equations. When you're solving equations, the big ideas were you got to make the equation equal to 0 first. And after that, you can either solve by factoring or using the quadratic formula. So why don't you pause the video and try to solve each of these 3 different equations and then check back in to see how you do. Here they all are. 2x squared equals negative 5x. So if I bring that to the other side, 2x squared plus 5x equals 0. So I've got it equal to 0. Now I factor. Either this factor equals 0 or this factor equals 0, in which case x is going to be either 0 or negative 5 over 2. In this example, I set it equal to 0, and then I simplify. Here's my equation. Now I factor. This is a simple trinomial, so I can easily factor that. Either this factor equals 0 or this factor equals 0, in which case x is either negative 4 or negative 8. In this third one, I make my equation equal to 0. I start factoring. Oh, I can't factor this any further because I can't find two numbers that multiply to negative 6 and add to negative 10. So I will use the quadratic formula. A is 1, B is negative 10, C is negative 6. Plug in my numbers. And as you look through my work here, you can see I'm simplifying my radical the same way I did in the previous examples, and then this is my exact answer. Now, if you wanted the approximate answer, you would then do this calculation once with a plus sign here and once with a minus sign there, and you get two different answers for x. But if the question asked for an exact answer, well, you would stop here. So just remember, when you're solving an equation, make sure it equals 0 first, then solve by factoring or solve using the quadratic formula. We also looked at determining an equation given the roots of the function. The function has roots -2 plus or minus root 2 and passes through the point -2, 8. So remember, if we know the roots, that's like knowing the x-intercepts. We can start with factored form. And once we have factored form, we can also substitute in x and y for the other point that's on our function, and then we can solve for that a value. And once we have that, we have the equation. So why don't you pause the video and try this one on your own to see how you do. Here's the general form for factored form. R and S are the roots of the function. So if one of my roots is -2 plus root 2, and I'm subtracting that, I would have x plus 2 minus root 2. And if the other root is -2 minus root 2, and I'm subtracting it, I would have x plus 2 plus root 2. Now I need to solve for that a value, so I'm going to use -2, 8 as the point that I'm substituting in. X is -2, so replace x with -2 wherever you see the x. And y is 8, so wherever I see an 8, or y, I replace it with an 8. Now I have enough information that I can solve for a. So I start by simplifying in the brackets. -2 plus 2 is 0, so I just have -root 2. In the second set of brackets, -2 plus 2 is 0, so I just have positive root 2. Now if I multiply these together, it's negative times a positive, so my answer is negative. Root 2 times root 2 is root 4, which is 2. So I have a times -2, which is -2a. To solve for a, I need to divide by -2. 8 divided by -2 is -4. So now I know the value of a. And now that I know the a value, I can write the equation of my function. Y equals -4, x plus 2 minus root 2, x plus 2 plus root 2. Now, if the question asked for standard form, I would then have to proceed to expand and simplify to turn this factored form into standard form. But we already covered that in this lesson, so I'm not going to go over it again right now. And the last topic we covered in this unit was linear quadratic systems. Remember, we're finding the point of intersection of a line and a parabola. So you might have 2 points of intersection, you might have only 1 point of intersection, or you might not even have a point of intersection. Whatever you do, to find the points of intersection in a system, you combine the equations, and then you'll have to set it equal to 0 so that you can solve for x. Once you know what x is, plug that back into one of your original equations to solve for y. Now you have the point of intersection. So pause the video and see if you remember how to do this. So first I combine the equation of the line and the parabola. I set it equal to 0 and I simplify. Now I need to solve, so I can either solve by factoring or quadratic formula. This is pretty easy to factor, so I did that. X is either 2 or 4 when I solve. Now that I know what x could be, I need to figure out what y could be. So when x is 2, I plug that into my linear equation and I solve for y. Y is 1. When x is 4, I do the same thing and I get y is 5. So my points of intersection are 2, 1 and 4, 5. So remember, combine the equations, set it equal to 0, and solve for x, either by factoring or quadratic formula. And once you know what x is, solve for y, using one of your original equations. Once you have x and y, you have the coordinates of your points of intersection. That's all we've covered in this unit in a nutshell. So if you have any issues with that, you should reach out for help. Otherwise, you can get started preparing for your unit test.